Okay, this is video 2 of capacitance. If you haven't watched the first one, I suggest you go ahead and click back to the first one. It has important information where we reviewed all the equations needed for capacitors. So we're going to go ahead and do this medium to advanced level of a capacitor. And so the first thing we want to do is go ahead and see if we can come up with a reduced circuit, because right now it's got a lot going on. So let's see. If we look here, we have a parallel circuit. We have C3, C2, and C1. And if we, well, actually we need to label those. So if we see this chart below, we actually have the amounts. So C1 is 3, C2 is 1, C3 is 4. And let's label the rest. C4 is 1, C5 is 6, and C6 is 2. So that is our capacitance for each of those. Okay, and we also know that the battery has 100 volts. Okay, so back to this being a parallel. So if you should remember from parallel circuits that the capacitance equivalent is just added together. So parallel, we just add together the capacitances. So 4 plus 1 plus 3, we add that together and we get 7. Or, sorry, 8. Can't add today. Okay, and then we can look over here and we have another parallel circuit. So 1 and 6, this one is 7. Okay, so I think that's pretty much all we can do for right now. So we can go ahead and create a reduced circuit. Okay, let's see, I'll draw it right here. So we have 8 here. Then we have 7 over here. This is our battery, and usually you want to just have one longer and one shorter. And then here we have 2. And then don't forget this is 100 volts. This is microfarad, microfarad. Okay, so what you want to notice here is that this is in a circuit. So we have 8, 7, and a 2. It's all in a circuit with the battery. So what we can do is for a series, C equivalent, we do 1 over CEQ equals 1 over C1 and so on, and add them together. So let's go ahead and do that. So let's see, we have 1 over 2 plus 1 over 8 plus 1 over 7. And according to the calculator, if you go ahead and do that, and then you do the reciprocal, CEQ equals 1.3 microfarads. So that is the amount for your battery. So we'll go ahead and put that right there. That's the capacitance for the battery. Okay. Now we can actually finish out this battery. We should remember that, okay, we're looking for the charge for battery. So Q equals C times V. Q equals C times V, so it's 1.3 times 100 is 130. And then remember, charge is in microcoulombs. So we put that there. And if we want to just go ahead and finish out the entire row, remember U equals half QV. So the potential energy stored in this circuit is half QV. So if we do half, let's see if we can see that, 0.5 times Q times your voltage, which is 100, you get 6,500 for your U. Okay? Alright, so we've done that. Now we need to go ahead and fill in these other lines for these other ones, okay? Alright, so let's see what we can do next. Alright, we know the battery is 130 microcoulombs for the charge. And note that in a series, the charges are all the same. Okay, so C6 is going to be 130. And C6, remember that's where we have the 2. Now, this 7 here has some more going on because remember it's not really just 7, it's also that 7 and the 1. And then the 8 has the other ones, the 4, 1, and 3. So we can't just go ahead and say that this is 130. It is, but we have to also break it down to the other ones as well. Okay, so what we'll do is write that in here so we remember that that's part of it. And that's part of this too that we need to work out. Okay? Alright, now let's see, what can we do? Well, we can go ahead and figure out what this voltage is for C6, so we can just go ahead and finish that one out. So, let's see, voltage is Q over C. Voltage is Q over C, so 130 divided by 2 is going to give us 65 volts. Okay? And again, we can go ahead and calculate the energy, so half of 65 times 130 is 4225. Okay? Alright. Now, alright, so we know, let's get back to these other two that are kind of making us feel a little stuck at the moment. So we know that 7 has a capacitance of, well, this capacitor has a capacitance of 7, and it also has a charge, a Q of 130. So let's go ahead and figure out the voltage. So voltage is Q over C, again, we just did that. So Q, the 130, divided by 7 is 18.57. So we're just going to keep those 2 decimal points. So because they are parallel circuits, the voltages are the same. Notice that V equals V1 equals V2 for parallel. So both of those are going to equal our 18.57. So let's figure out which ones came up with 7. So they are capacitor 4 and capacitor 5. Okay, so we're going to put 18.57 volts and 18.57 volts. And now we can just go ahead and multiply that out. So capacitance is charge over voltage, or Q is C times V. So just go ahead and multiply that out, and we'll get 18.57, and 6 times 18.57, you should get 111.42. Okay, we're going to do that same idea with this 8. So remember we did the division. 130 divided by 8. We get 16.25, and because voltage is the same in a parallel circuit, you can go ahead and put that down for each of these. Go ahead and multiply those out. So 3 times 16.25, 1 times it, and then 4 times it. And then we'll go ahead and do our U. So U equals half times Q times V. If you go ahead and do that, you should get these numbers. 396, 132, 539.9, 172, 42, and 42, 1034. Now, a good way to check this to make sure that you got the right answers is if you add all of these together, they should add up and equal 6,500. So go ahead and do that, and you should see that you're very close. There will be some rounding errors because we didn't quite keep all our decimal points, but it should be very close. So that's pretty much it for this one. This is a longer video. It was a little more complicated, but hopefully you can see how you can reduce your circuit into a much simpler one, and how you can use that information to figure out your different circuits and your different capacitances and so forth, okay? Alright, well, that ends the capacitor, and now we will actually move into resistors in the next video, which is using very similar information, but it's a little bit different. So that'll be a little more extra practice with the same concept. Alright, well, see you then.